This is like basically like the concept, like how this is how we hope that to work in the future. So this is like a very nicely presented overview, like a professionally painted. Like right now, like the picture is a little bit more of a sketch, as you can see, not that perfectly drawn, but this is like more or less what we have implemented by now. So what are the main parties, the main components? We have, of course, the user, we have provider, so someone who provides the infrastructure, and we have everything in between that makes it possible for the provider to provide a piece of infrastructure to the user. So everything that will happen in the demo is about giving the credential that later are used by the client to connect to the cloud, like AWS in that example, but S3 AWS in that example, but of course, like we aim for any infrastructure. And this is of course done with the assumption in mind that this is, I think that was already called like that today, that this is like a kind of like a DevOps for the people. So you could use like any backend you want, but without necessarily setting up all the accounts, having all the knowledge to deploy everything you need by yourself. And this is the economic part, so you just buy the piece of infrastructure. So how we do that? Like, of course, the first problem is in that setup for the user to find the offer that matches the needs. And of course that needs provider to advertise somehow with the offer. So the assumption here is that we use just a Wildland container. You can see this is a Wildland container where all the offers are grouped. At the moment, the assumption is that we have only one provider, and like there is no trust model built into the system. So we just assume that the user trusts that given provider, that the provider is honest. So the provider published the offers in this public Wildland container. Those offers are signed.
Let's say reliable, not honest.
Yeah.
Because we can always use encryption to make sure, and integrity protection to make sure that the provider cannot sniff or inject.
Yes, of course. Like well, everything is built around the assumption that we have as little trust in the system as needed, but sometimes you have to trust that there will be.
But it's a trust
uptime.
in availability, not in privacy or other types of.
So the steps are as follows: provider registers like him or herself in a smart contract, in United Payment System smart contract. The same pub key is used to sign the offers that are in the Wildland containers. There are many reasons to put the offers on the Wildland container, not in the smart contract. Basically, this is like the interaction with the Wildland container is much more smooth and much simpler than the interaction with the Ethereum smart contract. This Wildland container is public, so user can just examine all the offers and then choose the best offer. And then what the user does, user submits a transaction to the UPS smart contract with the payment. So this is like a kind of escrow transaction using one of the mechanics for the Ethereum-based tokens, and asks for that given offer with its hash to the provider, and then provider who has to monitor like what happens on chain has an option to confirm like the transaction and takes the payment, the day payment, and publishes encrypted credentials on chain as well. And those credentials are then used by user to access the backend. And of course, like what is exciting, especially exciting to us, is what happens like behind the scenes after after provider accepts the contract, takes the payment goes there and publish credentials, and then like most of the payment goes to the provider, but some of it is swapped to GNT, to Golem network token. At the moment we use Uniswap. Like we will see like what we will use in the future. At the moment Uniswap seems to be the best solution. And then this GNT is used like to be like permanently removed from the system, and the corresponding number of proof of usage. So like this, for a lack of a better word, like a voting power in the organization is created. There are some nuances here. Probably the most interesting for people from the token space is that although like the transaction is in DAI, we assume that we'll generate proof of usage on one-to-one exchange rate to GNT. So like depending on how the price of the GNT will change in the future, that will affect like your historical weight of proof of usage comparing to the newly generated proof of usage. Yeah, this is interesting, but perhaps not necessarily for that demo. And of course, like the other part of the payment goes to this like a dev fund. This is like a sweet picture.
It's very cute.
That is later used to finance the development of the system or of its components. And by the way, we assume, of course, that all the core works, all the core protocol works, everything we do as a Golem Foundation is financed from the resources of Golem Foundation and not from that fund. This is for the future. This is like to ensure like a long-term sustainability. Because if we have a problem with something as a world, I would say, it's the sustainability of interesting initiatives. Okay, I think that's enough for me. I gave you like the overview.
Hi, my name is Pepesza, and I will present you the work which has been done on Wildland agent. So, yeah, we're online. So, Wildland agent's role is basically buying and managing storage for the user. So first a few words on my setup. So I'm running a GEF node here. It's a full node, which requires a separate SSD disk. Okay, so this is a proper GEF node. I'm using it to develop and test contracts. So why do I do that? Because it's a mainnet node also.
Okay,
why do I do
can you just tell us what's on the left console?
Yeah, this is at the moment that's a view of the Ethereum node. So I will switch from it right now. So now I will launch a local fork of this Ethereum node, which will contain all the changes and all the tests I will do. Now, when I have my own copy of Ethereum and I don't need to pay those crazy fees, which we observe right now on the mainnet, I can just deploy all of the contracts. This is basically Truffle Migrate does this for me. It should be called Truffle Deploy probably. I just click it and I will observe this deployment going on the right hand side. And now we're done. So now my contracts are deployed. The contracts consist of three parts. It's a registry of sellers, which basically the place where any buyer will go to check like who is on the market at all. Next, there is a market contract, which will help sites to make deals. And the last one is the contract which interacts with Uniswap, and it basically swaps DAI for GNT. Those contracts, like the swap contracts, they are in a way, they can be exchanged. So if anything will go wrong with Uniswap, we can just deploy something else and it will work. Okay, now, since we have our, we've deployed the system as a whole, now I can deploy my own shop. So I will switch to the next tab. To deploy the shop, I need to do two things. I need to deploy the HTTP side of the shop. So at the moment it's HTTP. It will be moved to Wildland container in the next iteration. But at the moment it's just an S3 bucket with a list of files. So to deploy that, it's as simple as copying offers to the.
Can you show one offer? Just as a...
This is what I'm intending to do. So I will show one offer just to show how simple are those offers. They can be automatically generated or by hand if somebody wants to do that. So what do we have here? Information about the size of the storage I'm selling. It's 50 gig. The provider, which will be on the back end of the whole thing. Country, which will host the data of the person who will buy the storage. Some additional information. The time unit I'm selling, the price, and the price unit. We're using DAI at the moment for transactions. So as you see, it's very, very basic and very simple. But if we will get a lot of those offers, then we can have automatic price discovery and we can have all the niceties of market. Okay, so at the moment I have only 3 of them. So I just need to copy them to my S3 bucket. So it's simple as calling S3 copy. Like in the next iteration, it will be replaced with a proper automated call by Wildland in the agent itself. So at the moment, you can do it by hand.
So we will put the offers onto a Wildland container, not to directly infrastructure-specific thing like bucket. So let's imagine I've deployed all the other 2 files. I also need to copy the index file, which will represent the list of the files. It's limitation of S3. We will not need to do this on the Wildland container. S3 requires me to do this. No. It's index. Yeah, that's a technicality just for testing. Normally, of course, we wouldn't be forcing agent to parse and index HTML to get a list of files. Again, we're not gonna be using it because we're gonna be using Wildland container for that. So that's just a technicality.
Yeah, and now my shop is ready it's accessible from the web, and I can register it in the smart contract. Yeah. So what's going on in this command line? So this is the agent binary, Python script. This basically, I'm saying that I'm a seller and I want to register my shop. This is the URL where the shop is deployed. And the last one is the address I will use. Addresses are managed by Ganache locally on my machine. This is the source of the address and the. So
what Paweł is doing, he's operating on a copy on write copy of the Ethereum singleton blockchain, and is deploying the contracts on his own local copy of the blockchain, just not to need an actual gas and ethers to do it for testing.
So I will deploy it. It's okay. Okay. So what happens if you see here the message on the bottom? It says missing tree node. So what happened is Geth locally has garbage collected the state which Ganache was operating against. So it's the artifact of my setup. So what I have to do right now, I just need to repeat all the previous steps. Just a little bit faster, and it will be just fine. It will work just fine. So this type of problem will not happen if you work against Infura on paid account, because Infura will store all of the state for you. But unfortunately, when you do it locally on Geth, sometimes that happens. So I'm running contracts again, and I will deploy the shop once again. Yeah, so the shop is deployed, and I can, if we were on proper mainnet, I would be able to see this transaction at this time.
The provider you see on the screen here, WAgent seller register shop, talk to the seller contract on actually this little copy of the blockchain here on his local computer, and created a representation for a provider.
Yeah, exactly. And also you can see this transaction on here on this left console, on the right console for you, and it costed like almost 80,000 of gas, which is probably, it's not a big transaction, but it will be costly in today's gas prices. This is the reason we will move the whole thing on to L2 when we will have something to work with. By the way, the first L2 smart contract ready implementation will probably be optimistic rollup by Plasma Group. And they've published their smart contracts today. So you can actually, if you want to play with it, you can start doing it today. Okay. So the next step, basically, the shop is ready. Now we can switch to the user tab, our client tab, and see what's in the shop. Agent, buyer, offers.
So now we are on this green laptop, simulating we are at the user's computer, and user wants to see what are the offered backends.
Yeah. So when buyer will try to check what the offers are published out there, it will connect to the Ethereum network. It will next list all of the sellers, and it will iterate through all of the shops published by sellers. Yeah, it's just offers. Yeah, so what happened here? It looked up mainnet, Ethereum network. It saw that there is one seller deployed, and it was deployed by this address under this location. Now it gets the shop contents and lists all of the offers. Obviously, this information is a debug information. Normally, user will never see this, because what we intend to do is to have an automated market where user just specifies what he wants and his wallet, and the agent will get the best offer for him. I will show you how it works. Okay. So.
Why some offers are in DAI and the others in USD price? Just out of curiosity.
There are some. Oh, okay.
We've been just.
Yeah, there is one USD price, two USD prices here.
Heterogeneity.
My bad. Okay. Yeah.
These are just exemplary offers.
Yeah, those are just exemplary offers. It should be in DAI, obviously.
Transition from fiat to crypto is.
Yeah. It's not easy.
Even for Pepesza.
Exactly. So I will show you what I want from the, what type of storage I want to buy. I've prepared a file with this. It's called request YAML. It's just a simple YAML file. It's very short. So I want to get 60 gigs of storage, and I want it to last at least until the this date.
When Paweł says I want to get, what he really means is that the client working on behalf of the user at this green laptop, the client wants this kind of storage, perhaps to store the user's cut photos or whatever somewhere, or maybe some other containers.
Yeah. And what I will use for this transaction extra is the credentials. Those credentials are basically, since different providers will use different access protocols, possibly, which are pluggable. We don't make here assumptions about the form of credentials, but we want those credentials to arrive to us in encrypted form. And this is the bit which says, please use Ethereum key and encrypt those credentials for this Ethereum key. Yeah, now I will run the transaction, which will place an ask for the storage on the market. The next step will be seller's agent will automatically check the state of the market, see my ask, check if he has the appropriate amount of storage, if he's ready to serve my request, and then it will confirm it. So, so this is the command. I am a buyer, I want to create a new lease for storage. This is the request I've just shown you, and this is address I will use to pay in DAI for the storage.
This is address of the contract that is used for transaction.
So what happened here basically is we've browsed the market, we've got 3 offers, and here I'm running the very simple mechanism for automatic selection of the best offer. Since, as you remember, I had 3 offers here on the market, and the smallest of them had only 50 gigs. Obviously, I needed more. Thus, this one offer was filtered out, and I've just picked the cheapest of the other 2. And this is it. So it's 100 gigs for $10, for 10 DAI. Yeah, and after that, I'm just creating an ask, and I wait for the confirmation from seller. So this bit is marked as simulation because this bit is not yet ready, but normally the program would halt here, and it will wait for my transaction on the seller's console. So
let's ignore the mismatch of the currency. Currencies there in the offer. And
what I need to do, what would automated seller do? It will check if he has the storage, and then it would run the Ethereum transaction. So here I can do this for him, and it will just read the Ethereum network and basically confirm the transaction on Ethereum. So what happened inside the transaction is my client was.
Can you move it to the top of the screen? Because it's behind your.
It's behind my head. So what happened here in this transaction? The client got his credentials, which were delivered. Basically, there is one missing piece here in this command, and it's passing the credentials. The person who will present later, Mateusz, will show you how the credentials are created and other parts of the stack. But basically, if seller will run this command, on other side of the world, user will get his credentials through the Ethereum, and agent, this is the user's console, will create a response for him, and this data will be used by Wildland client to create a storage manifest, which will be later integrated into the user's infrastructure.
So, as you saw on the Marek's and Paweł's demos before, they created manually storage manifest for S3, and Marek used some actual real S3 credentials there in the storage manifest, which he obtained through his AWS management console, probably, which he paid for with his credit card and read documentation how to do it. Now this is just bought as a ticket on the marketplace automatically. So this is this part, how to get it without having AWS account.
Yeah, here all you need to all you need to have is basically software and some crypto, and you can do that in a single or maybe in 2 clicks.
Also, what I think is interesting in that setup is that there is in fact no direct communication between the user and the provider.
Yeah.
Yes, so don't need to traverse nuts or whatever.
Also, maybe Paweł, you could comment on the scalability issue. Maybe first, what is the scalability issue?
Yeah. So the problem today.
Perhaps not everyone is aware of it, and then what we are going to do about it. So if we are able to do something.
The problem today is gas on Ethereum is very expensive because of some interesting stuff going on there.
And what is gas?
Gas is the unit of payment. Maybe it's not. It's a unit of work on Ethereum network, and you need to pay for the gas with Ethereum, with Ether. So it's basically the supply is very limited. It's 10 million gas per block, and it's not elastic. At the moment, it's actually 12, and it's not elastic at all. So the result, if you have a very high demand, the price goes up as far as it needs to go to basically remove any user which doesn't want to pay as much. Today, for instance, this transaction would cost somewhere around $2, which is way too much basically to pay for storage. You can do it with credit card way cheaper. That's why we will be this demo it works against Ethereum, but we will be building on top of L2 as soon as the first L2 will arrive. We are not sure which one it will be yet, but obviously this move is needed.
And it also requires user to have both Ether and the stablecoin, right?
Yes, at the moment, yes. And the L2s might be a bit more elastic about that. So it depends on different implementation details. But for instance, ZK Sync today, as far as I know, it allows users to pay in the arbitrary token, which they're using. There is a wide list of tokens, obviously, not any token. Yeah. So this is how it looks.
Do you have
I'm sorry.
Questions?
Yeah, questions.
Discussions?
You said that the offer is signed by the shop. Where is it exactly? Because
Yeah. So it should be signed, and it will be signed in the next iteration. It's not ready for this demo. Yeah. So at the moment, what it does instead, it checks if the hash is known, hash of the offer is known, and if price is correct. So there is a chance that the user was cheated somehow by the provider in the middle, but we can actually remove this problem just by checking the correctness of hash. We don't even need to check the signature. If hash is correct and the seller confirms that he knows this cache and he runs confirm, we are done.
Yeah, but this is not perfect solution for the simple fact that this expose user to some malicious behaviors, and only provider is able to verify that.
Yeah, at the moment, yes.
And if the offer is signed by the provider, then user can verify if this is a legit offer.
Yeah.
So.
I have a question regarding currencies. Because right now, decided which offer was the best because all of them used the same price.
Yeah. It's a great question. So what about different stable coins or different coins? What we intend to do is use multiple stable coins which represent dollar. So it will be at least DAI and USDC. And then we can, since they track each other quite closely, we can leave this topic to the seller itself, is to decide if he cares about small differences in price of the USDC or DAI versus USD or not.
To phrase it differently, one of the reasons to have the marketplace in the Wildland container and in the smart contract is to be able to create as many offers as you're able. So if you have one gigabyte of space for sale, you can make 10,000 of offers on it, with different currencies. And then
affecting the request store, it means that
the matching mechanism, of course, is a tricky part, and especially as we want that to happen as seamless as possible. So we don't want, in fact, we don't want something like you have in a Dropbox or like any other cloud storage provider, that you browse to the different plans and then you select the plan. We want that to happen seamless because of many reasons. Like maybe this is for like a very, very long discussion why. But then this really can be done to work on as many currencies, as many sub-markets as you wish. Like the only like a limiting factor is like what can be processed through the payment system. But then also you can imagine like a different layers of the payment system. So I would say that at the moment the biggest problem is this scalability. Like I would repeat the same what Paweł said, but like in economic terms, this is only as many transactions and as much transactions, as much complexity allowed on the Ethereum at the moment, and the demand is very high, and that pushes out all the use cases like this one, where like the transaction cost has to be in cents or in a fraction of cents, and not in dollars or $10, because like actually like a $2 fee for that transaction is an optimistic scenario right now. That could be like a $20 or even $200 at times. So
but right now in the request we don't define our currency. As I understand, we define only requested size and
Yes. Yeah. Basically, we assume that market is efficient, that it can actually deliver us the best offer, and that's why we look for all of the offers and we find the best which satisfies the criteria.
I think that the request should only define the maximum unit price, like in something, and then that will be up to the agent. Like so, you match everything locally, and like the order processing is done locally. This is not like the matching is not on chain. Like you just take all the offers and then you match them locally, and you just select which offer you select.